All right, we're going to talk quickly about searching and then sorting an array and look at some basic searches and sorts and to trace out kind of what's happening with these. So we start with some number lists. Let's say that this is our numbers, and important to notice that it's not in order. And we'd have an index 0 through 5. Again, the length would be 6 because there's 6 items. And then our first search is just a linear search where let's say we have some target of 16. We're trying to find where 16 occurs in the array, if it does anywhere. And basically, we just go through each piece of the array and compare it to the target. So it's a very simple search. So I have some iteration. I have my target, my index, numbers of that index, and then is it equal to the target? That's my condition. That's over here. So first time through, the target is 16, index is 0. Right, so I'm just starting this for loop here. Index is 0. Numbers of 0 is going to be 23, and is that equal to 16? It's not. So I loop through again. Right, this is my second iteration. Target still 16. I'm at an index of 1. That's 42. Right, so there's 42. That is not equal to 16. I go again. My third iteration, target's still 16. This is 2. I look at numbers of 2, which is 4, which is not 16. So I keep going. I get to 4. My target's the same. I look at my third index, which is 16. And at that point, I return a value which is going to break my loop. And so I return that index value. I return 3. And, I'm sorry, 4. Yes, index 3, and so I get where that 16, where I met that target. And I can notice if I didn't go through that, if I went all the way through, I would just return -1, which would indicate I did not find that value in my array. And so we can do something that's very methodical and will take a long time as we kind of compare each item in the array. We can be a little bit more clean if we have an array that's already ordered. So if we have a sorted array, let's imagine this is our sorted array, and we use what's called a binary search. And so a binary search basically looks at the whole thing, then looks at a half, and then a half of a half, and a half of a half, until we get to our desired output. And so we do the same thing where we have our numbering from 0 to 5, and our length is going to be 6, and then we have a while loop. Right? So we have a couple of things to look at. We have our iteration, we have our target, we have a low value, a middle value, a high value, and we have some condition on the while loop that we have to meet, and then we have 2 other conditions that we're going to try to meet as well. One within the loop, one outside of the loop, and we'll try to see how those 2 work together. And so if we break this apart, we start with our 0 iteration. This is before we enter the loop. We set our target to be 16. Our low is 0. Our high is 5, or our length -1, so 6 minus 1. And then we add those 2 together, and since we're doing integer operations, instead of 2.5, we get 2. That becomes my middle value. And so then I see if I can enter the loop. So I ask, is 15 not equal? So I'm looking at numbers of 2, which is 15. Is that not equal to the target, which is 16? And is my low less than my high? And in this case, this is true. So I'd enter the loop. So I enter this while loop here. This first condition is met. And then I ask the question, is my target less than numbers in the middle? All right. So target less than numbers in the middle. Middle is 2. And I look at that value. So if it is, right, then I'm going to, this is my first iteration. So I have my 16, 0, 2, 5. And now I ask that question on that one, is 16 less than 15? That's not. So instead of doing this if statement, right, I go to this else statement. So I set my low to be my middle plus 1 more. And then I recalculate my middle. So my low is 3. My middle becomes 4 when I take the 3 plus the 5 divided by 2. So the low plus the high divided by 2 gives me 4. Okay? And then I go back up and I ask the question, am I still in my while loop? And so I go through with those values. My second time through is 23 not equal to 16, and 3 less than 5, that's true. So I again go to my condition here in the middle, and I see, is my target less than numbers in the middle? Is 16 less than 23? It is. So in this case, I make this true, and I set my high value to be my middle minus 1. So my high value becomes 4 minus 3, or 3. And my middle gets recalculated to be 3 plus 3 divided by 2, which is 3. And then I figure out if I go into the loop again. All right, so I'm back up at the while loop, and ask the question, is 16, that's numbers, is my target, is numbers of 3, which is 16, not equal to 16, and is 3 less than or equal to 3? Well, this is a true statement, right? So this comes back as false. This is true. Sorry, 16 is equal to 16. This is false, so this gets short-circuited. This condition doesn't get met. So I don't enter the while loop, right? The while loop is done. And now I execute this part. So I try to figure out what's going on with that. Is my numbers of 3 equal to the target? So is that value equal to 16? It is. If it wasn't, I would return -1, which would say that I didn't find those values. So a much shorter way to find a value, but the key part is that the array must be sorted to begin with. So we can talk about a couple of ways to sort an array, and these take a while. Our first up is our selection sort. And so, again, we start with some array, and it's not in order. We're going to sort it. And we're going to loop through it with 2 loops here. So I have my indices, I'll have number them. I have 1 for loop there. I'm going to have an iteration, an index, and a min that are set with that. And then I have another for loop in there that I'm going to iterate through. I have a scan, a numbers of scan, and then I have numbers min, and then I have some condition on those, and that condition is right there. So I'm looking at how those conditions are met. That's my green for loop, my iterations, that's my blue one, and I start plugging through it. And so I start with my first iteration. Index is set to be 0. All right, this is still true, and then I'm going to set min to be index. And now I iterate through this one. Scan is index plus 1, so 0 plus 1 is 1. And then numbers of 1 is going to be 42. Numbers of min, which is 0, is going to be 23. And so then I ask the question here, is numbers scan less than numbers min? Is 42 less than 23? That's false. Right? So I loop again. I don't execute this statement here, but I continue to loop through. So my second iteration, scan is 2, numbers of scan is 4. Is 4 less than 23? It is. It's true. So what I do is I set min to now be 2, to be this scan value. That's the lowest one I've found so far. Index is still 0, and now I iterate the third time through the green loop. Now this is 3, that's 16, so that becomes 16. This is 4. All right. Numbers of min is 16 less than 4. It's not. That's false. So min doesn't get changed. It stays at 0 and 2 for index and 2. I loop through it again. My fourth iteration, that's 8. 8 is not less than 4, so my min stays at 2. And I go through again. There's 5, and then that's 15. 15 is not less than 4, so that's false. And I'm at this point of my value is 5 less than 5, I would iterate again, scan plus plus. Means this is now 6. 6 is not less than numbers length, which is 6, so I exit out of this loop. And so now I deal with this value of swapping those things that I found. So temp becomes 4, which is this value of numbers of min, and min is 2. So I get this value here, and then what I do is I set numbers 2 to be numbers 0, the index value. So I'm going to swap the 4 and the 23. Those get switched, but I got to realize that now I have this value 23 in here twice, which is why I had to create the temporary place. The temp goes here, so number 0 becomes temp, which is 4, and my array now looks like that, and we've got the lowest value set at the first part of the first index in our array. And now we iterate through the second time of the blue loop. We've only done it the first time. And so we go through, and now it's my second iteration. Index becomes 1. Min is at 1. And I iterate through my green loop now. And now that scan becomes 2. And you can notice here that I'm going to compare. I no longer look at this value, the 0 value. We've dealt with it. So I start here, and scan starts there. So I'm going to start looking at anything bigger than the one I already know to be the smallest. And so I would run through it, 23 and 42. 23 is lower than 42, so my minimum value now becomes 2. I iterate through the green loop again. Scan is 3. That's 16 for numbers of 3, and then that's 23. That's true again. Again, I get my minimum to move down. I iterate it through to be 3. Scan is 4. That's 8. That's 16. That's true, so my minimum value would switch again. right? I get all the way through, and then I'd swap those values again, and now I'd have set this value to be the next in the list. It would have been 8 if we gone on through it. So it takes a long time. Again, we'd have 5 iterations here, and each of those 5 would have 5 iterations within there. So we'd have 25, or our size squared, to work through this sort in our worst case scenario.